Here is another tolerant movement in robotics for knee bending like a human. So that's the feet, that's the knees, that's the pelvis, the biaxial lump. Here's another humanoid motion of stepping and of motion of the legs, where the knee is straight down here and the leg is crossed backwards going here with the feet at the back and the knee there. So that's another motion. Here's another humanoid motion. A human motion is like a humanoid step. Here's the horse step in the robotics for horse. Okay, so there I have the biaxial for the worker. I have also the damper, the servo, that will act as a damper with an shock between it. This will press against a piezo, pressure sensor, actuator. This right here is the axis for the knee. This is for panning. Notice I put wafers on here so that it protects the screws from falling out. This is the toe for gripping, and I have the servo axle. This is for panning, and this is for tilt. This is for bending, and this is for panning, and this is for tilt. And for gripping for the toes to go over little rocks and stuff like that, little bumps, so it can have like an axis arch. Now right here is for the, like I said, for panning and for tilt, and for the damper the same. It also has horse. Here's the wafer right here for the armature to torque against the circle to turn inward, as for a horse. So trying to configure this self-balancing together. My name is Humanoid Morton. Have a nice day. Goodbye. Okay, so therefore I have applied the gyroscope chip here. I mounted it right here, so the pin mount can be local right here. So all I have to do is stick the pins in for the Arduino pin. Here's the human radar Doppler right here. So all I have to do is stick the pins in for the output if I want an external output to connect it to other units. Here's the piezo buzzer, and on top of it is a cell phone mobile vibrator. Here is the magnetic sense. Here is the micro camera diode. There is the coin battery slots, and all you have to do is push that lever back for the coin to come out. And here is the coin battery charger. Here is the speakers for listening, for hearing for the robot. And here is the Arduino Nano. I also have the phase wires just coming out here for the speaker, and the phase wires for the speaker over here, and the phase wires over here. So what I'm going to do is make this like a breadboard. So I have the adhesive tape, conductive tape, and I also have the copper wire that I'm going to use for the bus bridges to phase these different parts and wiring. But I'm going to make indentation so I can leave it traveling between a circuit, like a circuit. So I have the PIR, I have the diode sensors right here. This is for the light sensors. I have the color sensors. I have to apply the modular for the color sensors, and that's to translate the colors from the system. I'm going to put another piezo on here, so two of them will accumulate enough energy to auto recharge the coin batteries. I'm also going to use a synchronous induction coil here. These are 3 volts, and this is 3 volts. That enumerates 6 volts. I plan to put other volts down here, a coin battery here, and a coin battery here. However, that will make 12 volts, and the resource to power to each individual system. So, engineering morning, I'm still working on it. This is the neck. I have to use the pulley cables, not pulley actually. I'm going to be using servos to drive it, and I'm also going to be using lead long rod micro stepper motors, and so that will pull like a puppeteering to different angles of the system, and that's going to be local onto the servo mount, the servo bracket mount. So, I'm Engineering Morton. I'll be back. And I plan to enclose this. I plan to enclose this with latex over the exterior. If I could get the small little film, touch film mounter, I'm going to apply that within the system. I'm going to either put the PIR sensors and embed them in a direction so that when touching on against the surfaces, it will actually sense that the bending deformation of the surfaces. Or I'm going to use a flexible pressure sensors underneath the latex mask casting. So when I do cast over here and make the little holes for the mask, so that these things will not be exposed out openly, but hidden, then I'll reface, and I'll probably harden the mask in certain areas with epoxy resin, and build up a nose and different other parts and segments, a mouth, and optical rotating motion eyes. So, and my name is Humanoid Morton. I'll be back. Goodbye. Okay. The other plans that I had were for the knee is that the access of the knee, I had to have two servos to apply to that in a V connection of the brackets, the U brackets of the servo. So between the knee must be the V connection between the U brackets of the servo. That must operate as a damper, a mechatronic damper or anti-shock. That must also be applied to the lower part of the shoe, the upper part of the shoe bracket of the servo. And that must be two connected servos at 260 kilograms with a U bracket with a 90-degree angle pitch. And it must be connected together in an angular, like a V shape. So I guess, no, U bracket with an angular pitch. So I don't think it's 90 degree, but I think it's an angular pitch for the U bracket for the servo arm. And that must be applied to the lower part here to here, and to the knee, biaxial knee of the lower part of the axis of the knee of the robot. And that must also be applied to the abdominals. As far as the upper part right here, that must be connected with another V bracket for the biaxial tilt, and also for dampering. This assists in stepping over rocks. I also have it access so it makes climb over rocks. I have a toe for a gripper to cover over a rock with how can I say, a pitch angular. And I also have it for tilting, for self-balance. I also have that up here in the upper part of the frame so it may do that. So this may operate a task of trying to balance over the rock, to stabilize the grip of the rock, but this may balance the upper part of the body. So that's two types of self-balancing. Now in between that, it must need the V-shaped type U bracket, which connects two servos together that are at an angular pitch, at an angle from one another, like a triangle. And it should react as a damper to the system, a mechatronic damper. I find it better than regular dampers. And, you know, to calculate the metric range of the resistance, the anti-shock resistance. So I think it's better for a proper calculation of mechatronic resistance. Now, as far as the shoulders and the biaxial shoulders for arm and pitch, that will be 5 sets of servos. 1, 2, 3, 4, 5. That'll be 5 sets of servos without the hand, including the hand. That's 6 servos. So that will incorporate that part of the upper part of the framework. And the same thing that I'm using the same hub for the ROM for the arms. That is, I'm going to be using probably, I want to use 2, but a step down on size of the pancake motor, architectural drum motor. So I'm going to use a step down size for the to allow speeds, increased speeds for motion and movement, for punching and stuff like that. So this is going to be more like a miniature security robot. So, and I'm trying to make it fighting. The other parts of the segments, I have the piezo's on the way, piezo buzzers. Those are going to be used for, they're going to be used for, I guess, touch sensors. I guess for nerves, I want to make robot nerves because this is supposed to be enclosed inside of a latex rubber. And I want to use the pyroelectric effect with it, but the pyroelectric effect, I do want to have electrical circuits so I can control the electrical energy that is applied by, that is generated by pressure. And for a pressure sensor, so I want to send it through an electrorhythm to convert that into a thetra, a motion chip. This is dealing with the alpha frequencies where you have alpha, beta, gamma, delta, thetra. And I'm going to translate the acoustic pressure and acoustic hertz into electrorhythm. So I'm going to transfer the hertz of an express word or term, the expression being used in a subfield of an electromotive, so that the pressure that is applied, the reactive type for the pyroelectric effect, when bending deformation of it, exerts an energy through an electrical circuit, which is the electromotive, to translate the electrical current or the electrical rhythm, the electrodynamics, into an acoustic pressure. Acoustic pressure is the word that is being used. So it must pass, the piezo must correspond to a syntax or software-based processing into from the microcomputer to the output of to the microcomputer, and that transfers to the memory of the syntax script. And that is supposed to record that and also use that as for tasking and variables for switch controls to actually make a response or non-response out of a thetra frequency or alpha frequency. Alpha frequency is the loud frequencies, the high frequencies of the external mechatronic cues, which is actually the motion and movement of the mechatronic robot. Now, the lower fields are the lower energy or lower electromotive responses. So the lower it goes, the more it is not visible to the eye, to where it is driven in a subfield of the electrodynamics of an electromotive, whether voltage power up, power down, or modified to either pulse electromagnetics, pulse 1 or 2, depending on how the circuit drives the electrons through its induction, its current counter. So, in the output of the horn, actually, whatever it is, it will end with, as far as end with, whether it's processed just electrical energy, processed on the computer for writing, for itching, or for MFD, magnetic flux density, writing, as using a zip guard, as far as a zip SD card, because I do want to plan to add a memory card to each one of the servos and a memory driver to write the memory of each motion and movement of the proximity laser and PIR laser that actually checks the dial of the location of the servo and fixes the proximity of the axis or radius of the turns of the servo. So I want to record the events that are happening and occurring. I also want to record the external events, which is the exterior ring. I do have magneto Doppler linked to the PIR sensors, magneto-human radar Doppler connected to the PIR sensors and the PIR lasers and the rangefinders. I'm also going to be using the transducer to, along with the cameras that I'm going to be applying. The cameras that I want to apply is the mounting cameras, where they take over 100,000 photos per second, images per second, for proximity sensory to try to detect the area of the last area where the mounter was either localized. This is going to be used in augmented reality and self-balancing and motion and commuting and motion in an environment where the environment has either the deformation pitch of the ground, the surfaces. We're using the rangefinder and the camera to capture the image of the foundation of the floor as a walking robot when walking and traveling. In augmented reality, where the measuring software measures the distance and as of the geometry of the foundation it's walking on. The camera software also has image capturing, so it captures the image. It also, motion detection, and captures the image and syncs that through the variables through syntax script and to resource communities to find other related shapes or subjected to that particular shape, finding the image description and the translation of the image, which is captured by the camera. So a set of sensories is going to be used also for processing tasks and for walking or running. So the reason why I added these up is because I wanted to run. I'm also going to be using probably an actuator rod to move back and forth to force a certain pitch of motion and movement while walking or running. So I don't know if I'm going to be using like a chainmail bicycle type of effect with a band to cause each corresponding of the axis to motion along with it. So I don't know if it's going to be series attached to left and to the right, to the left, to the right, to the left, to the right by a series of belts, gear belts, and to cause it to operate like a bicycle operates with power and crank for one side, and as far as the other side, one is power, one is crank. So to cause the assist in the motion and movement of the servos, and along with the self-balancing. So this is a lot of different variables which I would incorporate in it. I had a lot of beatdowns and crashing it up and dropping it, but I'm getting there. I'm eventually going to refabricate the servos if I need to, and still is going to be encoded into the latex to make it like a puppet using puppet materials. I also want to use a Mouser film, so I don't know if I'm going to use a Mouser film or I'm going to add the conductive latex alongside with the PRS sensories where I have to localize them out here, but I don't know how I'm going to get it to do that unless I bend deformation. And the sensors that are localized to the surfaces find that the surfaces are bent and deformed, having an indentation which bypasses the passive light sensory and causes it to detect the signal that pressure is applied there. So wherever the sets of the PIR sensors that are localized there will be able to detect if there is a deformation within the exterior of the latex enclosure. So to try to get it to like a Barbie shape or a Kent shape, like a human, humanoid robot, machine. So I got a long way to go. So I'll see you later.